Hi, did you try this question? I hope you did, and you should be able to answer this question. This is always the first step to do any analysis or answer any question. And the answer to this question is this. Think about this problem in casual words. We would like to compare the probability of high cholesterol uh, between smokers and never smokers. So what we change is the condition. The condition is the whether uh, the person smoked or not. So our main event of interest is high cholesterol, but under the condition that the person ever smoked or never smoked. So this is what we compare, right? It makes sense when we explain the probability in words. And now we are going to calculate these conditional probabilities. And I said it is from real data, and I have real probability distribution table. From the data, I calculate the joint probability distribution table, and this is it. And from this table, we can calculate any probability. So conditional probability can be calculated also from the joint probability distribution table. And of course, you do not need so if you have the data file, you don't need to calculate joint probability first and then conditional probability. But there is a way to automatically calculate conditional probabilities, and I demonstrate how we calculate conditional probabilities on Excel in a separate video. If you are curious, you may watch that video. And also, it may be helpful to learn the basic skills for like in Microsoft Excel. And personally, I use pivot table to for my household financial book, so that I can calculate how much I spent on something like on food, or how much I spent on uh, things blah 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 blah. Anyhow, we are going to use this joint probability distribution table, and let's calculate. We will be calculating these two probabilities. In the previous definition, our definition was based on frequencies, and that was easy to understand because it simply count. I said like this many among these many candidates, and these many candidates are female, blah blah blah. But now we have probability instead of frequency, but simply there is no difference. To calculate the probability of high cholesterol among smokers, first thing you need to do is delete the observations not satisfying the condition. So delete these guys. They don't matter. They don't matter at all in this condition. And calculate probability of high cholesterol. That's it. And when you calculate the probability, just use these numbers, the probabilities, as if they are frequencies. There is no difference. So anyhow, it is ratio. So it does not matter at all. So if you calculate this ratio, you get 80.11%. So among smokers, more than 80% have a cholesterol problem. Now then, we may formulate this idea by going back how we got these numbers. So we used these probabilities, and these probabilities can be replaced by their notation. So we may write 37.99% as this event, so this part, and some of these two probabilities imply implies the probability of S. So, and you may understand this denominator as the probability of the condition, right? I explained it in the previous slide. So that's how we interpret this formula, and we have another formula for the conditional probability. This formula is what we derived earlier in the previous video, and now you may replace frequencies with probability. Does not matter. Doesn't matter. The point here is the condition in the denominator. You have to adjust the size of the condition, the pool size of the condition. So how many smokers or how many female, like those probabilities or frequencies, the frequency or probability of the condition have to be in the denominator, and numerator is easier to understand, right? Now, then, using this probability distribution table, try this. Also, it's straightforward, but I want you to do an exercise. Please try this. I am going to see you in the next video, and try this question first. Choose your answer, and compare your answer with the correct answer in the next video. See you.